Hi, everybody. Really quick, I wanted to talk to you about the second part of the conceptual design stuff that you've done this week. So, as I went through and graded, I noted a couple of issues that I wanted to direct your attention to. There wasn't a whole lot of problems with the first part, other than number 6 tended to stump people. And in looking at it, I can see why folks would have answered either B or C here. When we're talking about minimum cardinality, what I'm really interested in here is the degree of participation rather than the type of participation. And a lot of folks indicated that they thought the answer was C, whether or not an instance of one entity class is required to be related to an instance of another entity class, which is sort of the mandatory optional or type of participation, whereas B is referring to the minimum number of classes involved in a relationship. So that has more to do with the degree of the relationship, which is what cardinality is really pointing to. Folks did well with questions 7 and 8. It seems like we understand where we're at in terms of weak and strong entities and surrogate versus natural keys, which is fantastic. In addition, people did a great job interpreting entity relationship diagrams. There weren't really any issues with that. People got the supertype subtypes, which was great too. Folks also did a good job identifying the bridge tables and the role of the primary and foreign keys in those bridge or linking tables. Where we ran into a little bit of issues was with drawing the entity relationship diagrams. And one thing I want to note here is that you might be tempted to interpret these statements a little bit differently than how they're written. But what I'm asking you to do is to read these statements and to take them at face value. So whatever your logic is telling you, you don't really have to worry about that. So don't overthink it. Just go with the information that is right in front of you. So for number 12, we have one collection contains many artifacts and has a minimum of one artifact in the collection. An artifact is assigned to one and only one collection and must be assigned to a collection. So what that's telling us is that we want to have a one-to-many relationship where one collection, so that's our one side, has many artifacts, and that's our many side. So just to take a look at what that should look like, we have collection here on the left, primary key, a couple of attributes, and on the right-hand side, we have the artifacts table, which has the collection ID as its foreign key, because one collection has many artifacts. The foreign key is always going to go to the many side of the relationship. So kind of remember that as a trick that you can remind yourself of, but the foreign key is always going on the many side. You also were asked to insert the table schema for your tables. So if you didn't do that, you probably struggled a little bit with drawing the entity relationship diagram. Number 13, this also stumped people. So I was looking for a total of 4 tables. I took kind of variations of these things, but what we're saying is a band has more than one musician. So we're saying one band has more than one musician, and we're also saying a musician is part of 0 or many bands. So that's telling us, hey, we have a many-to-many relationship here, which means that we need a bridging table or a linking table. So take that part first, create those 3 tables, and then look at the next part where it says a musician plays many instruments. You could assume that many instruments are played by many musicians, but that's not what this is telling you. This is telling you to assume a one-to-many relationship. So when we draw that out, you wind up with band, musician, and instrument. You've got your bridging table here. You have your surrogate primary key, which is what I asked you to create. You're using the primary keys from band and musician as foreign keys in your bridging table. And then you're assuming that one-to-many relationship as stated, where you have musician ID as a foreign key in the instrument table. So that was your goal there. For number 14, it's another situation where you're going to need that linking table because we're saying a photograph may contain many subjects. Subjects can be depicted in many photographs. So this would, again, require a one-to-many relationship. And if you go to the Lucid chart that I created here, you'll see that. And actually, if I want to be more specific here, I could get at the optionality, which I failed to do in my drawing of this. But because we're saying that photographs can depict many subjects, and subjects can be depicted in many photographs, that's telling us, it's giving us a hint that's saying this is optional, this is not mandatory. So that's why we would leave this open here. I didn't take off points for anything along those lines. I was really looking for you having that relationship. And then I also asked you to have a composite primary key for your bridging table. So for that, we have photograph ID and subject ID. They're acting as a composite primary and foreign key. So the way you could indicate this here with your diagram, you could list these twice. You could list them together in the same line with a comma, separating them. It's totally fine. But one thing I want to point out is that in the actual database, you will continue treating them as individual attributes within a table, but you will mark them as both the primary and the foreign key. So that's what I'm indicating here in my diagram, just so that everything matches up between the diagram, the table schema, and the actual implementation of my database, which we haven't gotten to yet, but that's where we're coming from here. Number 15, one employee can marry one other employee. An employee can be married to one and only one employee. For this, I was looking for that recursive relationship that we talked about in the lecture. And so you just have the one table, and then you have the one-to-one relationship depicted for that table. So I think some folks maybe overthought that one just a little bit, but go back and review the recursive relationships if you're struggling with that one. And then finally, number 16, which I saw a variety of setups for this one, which again, I understand where a lot of folks came from in terms of their logic. And if your logic made sense, I did not take off points, but just to show you what I was looking for with this assignment, I'm saying an orchestra member may play strings, woodwinds, brass, or percussion. An orchestra member must be assigned one and only one of these instrument types. So if you go over to orchestra members, actually here, I made this really quick. So we're going to make this one and only one, because that is the relationship that is depicted here, is one and only one. I treated this as a series of subset tables with enum, which is telling us, hey, we can assign one and only one of these. But we have orchestra members, the member instrument, and then down here we would have the primary key for the orchestra member for each of these fields. So that's really what I was looking for here. Some folks just had two tables, which also makes sense. Anytime you get to a point where you're like, oh, I don't really know what this person is looking for with asking me this question, any kind of notation that you can add that says, hey, this is why I did this. This made sense, to me logically for this reason. Any kind of justification that you can provide is really helpful for me, who's going to be looking at your work and trying to understand the logic with which you're operating. So this is how I would have approached creating these, and what I feel is the most efficient. You might have had a different approach, and that's totally fine. So just so you have a sense of how to create these relationships successfully, at least one example of how to do it, moving forward with your own projects, how you do these, how you structure these tables is going to be up to you, right? So you are the designers of your databases, and it's going to be really important that no matter what you do, you have a sound logic that you're working with, and that everything lines up, right? So our goal is that we have this really nice overview of our database. We have our entity relationship diagram. We have our database diagram. We have the logical design that is really helping us define everything within our tables in our database. And then finally, we have the physical implementation, and everything is adequately reflecting what we want to appear in our database, and how we want to access that database and search for data. So that's where we're going with these assignments.